Hello students and dear viewers. How are you? I hope you're all good. Let's start today with a beautiful topic, a beautiful world of glass industry. I'm Professor Dr. Moina Mughal from Dr. M. Kaz Institute of Chemistry, University of St. Jamshedpur. And this is my presentation. What is glass? Formula for glass is R2OMO6SiO2, where R could be a monovalent cation, M could be a divalent cation. Glass is amorphous. Well, it refers to the atoms, that is, they are not ordered. It could also be called as a cool or supercooled solutions of multiple silicates. As its amorphous, it does not hold the properties of a crystal. It could also be called as pseudo-solids, that is, a solid holding liquid properties, as it is holding the proclivity to flow like a liquid, resulting to a thicker base as comparative to top of the glass. Now here in this page, you can see different types of decorative glasses, right? They are all beautiful glasses, they are colored glasses, and you can see glass doors, right? And these glass doors and the glass partitions, these are all examples of decorative glasses and partitions that are used in our daily lives. Pseudo-solids like glass is deficient in having a 3D regular positioning of atoms, as it's not a true solid, does not present sharp melting or boiling points. Now let's come to the structure of the glass. Silicon is the commonest cation that forms glass along with abundant and natural raw materials. Now naming limestone, calcium carbonate, soda ash, and sand, glass has the property to get hard without changing its composition to a crystalline form. Glass stayed in rigid form, attaining the amorphous form. Now, excellent form of glass can be obtained from silica possessing higher melting point around 3.133 Fahrenheit or 1.723 degrees centigrade. Extremely viscous, leading difficulties in handling. Glass composition. It is composed of 3 steps. Now, here in the picture you can see ingredients like formers, fluxes, and stabilizers play a vital role in its synthesis. Now here the man is mixing these 3 ingredients to form this white powder called the batch. Any glassy material holds key component, that is a glass former. For example, silicon dioxide is the commonest former used, as pure silica has a high melting point around 1723 degrees centigrade. So now here comes the role of fluxes. Now these are added to lower down the melting temperature. The picture below shows the furnace ranging temperature around 2400 degrees centigrade, ready for the batch to be added after thorough mixing. Formation of batch. Now mixing together soda ash, sand, and other compounds to form a batch, which is then pushed inside the furnace. Right, the picture on the right shows the furnace having the temperature around 2400 degrees Fahrenheit, whereas on the picture on the left it shows us the man making the mixture of sand plus soda ash to form the batch. Soda ash is used as a flux for lowering down the temperature of the sand. Standard fluxes are soda, lithium, potash, silica. Glasses holds added flux, can help silica to melt at lower temperature, that is around 800 to 900 degrees centigrade. During the heating period of a glass, if a glass has only silica and flux, they aren't durable, as these were water soluble. Let's talk about stabilizers. They make glass more durable, more stronger. For example, lime, CaO, magnesia, MgO, barium, BaO. The glass used to make windows, bottles, jars, light bulbs are more commonly used by ancient and modern glass makers, based on silica as a glass former, soda as flux, and lime as stabilizer. Let's discuss manufacturing of glass. Sir Leicester Pilkin, a renowned British engineer in 1952, innovated the float glass process. He was the man who initiated the idea of glass manufacturing by following 6 major steps. That is melting and refining, float bath, coating, annealing, inspection, and finally melting and refining. A batch composed of raw materials like feldspars, that is sodium potassium, dolomite, sodium nitrite, silica sand, and calcium oxide are mixed and heated above 1500 degrees Celsius in a furnace. Metal oxides are then added for coloring, resulting to get beautiful colored glasses. In the picture you can see metal oxides are added to these beautiful glasses to form these vibrant glass types. They are all so beautiful. Different metal oxides were added to make these colored glass jars and bottles. Now here you can see the beautiful colors of these colored glass jars and bottles formed by adding the metal oxides to them. Different metal oxides are added like iron to get green, sulfur to get blue, magnesium to get black, and so on. Float glass process in olden times. Now this is the picture, it speaks itself. Oh wow, it looks so beautiful. In the olden times, the float glass process looked like this. Float bath in modern times. From one end, molten end is flown down over tin via refractory nozzle, receiving plates of glass from other end that covers almost kilometers. Now here in the float bath process, silica sand, limestone, etc. are added into the furnace around 2900 degrees Fahrenheit, and it looked like a lava, allowed to run on the tin bath. Then again, when it reached lower down the temperature around 2000 degrees Fahrenheit, it turns into sheets of red hot glass and then flows refiner, that is other part of the furnace, that allows through a tapered canal where it is monitored. Then it flows the tin area. This glass is called the ribbon that floats on surface of the tin. The thickness of a molten glass is around 6.99 mm and uniformly flat on both top and bottom, as it is still floating on tin bath and is a liquid in the liquid state. The machines on either sides of bath attaining a pipe shaped having a wheel at end are for pulling the glass down the bath at around an angle 90 degrees with respect to the glass. It is programmed to attain the width and thickness of the glass by pushing and pulling. In this way, that angle is added or subtracted. The glass is allowed to progress further down the bath till it hits the temperature where it gets hard to hold its shape. The ribbon is then removed from the bath and allows to move forward to a layer that monitors, regulates the cooling or speed of cooling to make sure that glass will be of the quality they are looking for. This is a picture of Grisberg float bath glass line. Now here in the left side, you can see different stages in a float glass process. Whereas on the picture on the right, it conveys us how robots are monitoring the float bath. The float bath process begins with cold end area, passing thickness and stress measurement area, edge trim, cooling area, reaching cutting area. Both pictures conveys this idea. Float bath speed is monitored here, that is the picture on the left, whereas on the picture on the right side, this is end cap pack. Stage 3 is coating. As the glass flows down the floater, a number of coatings are deposited over. Stage 4 is annealing. Here the glass is slowly allowed to lower down its temperature by cooling, and internal strains are abolished to get it ready for cutting. Stage 5 is inspection. Here 100 million inspections per second on ribbon are presented. Stage 6 is cutting. Here the computer is fed the required measurements to cut the glass accordingly. Types of glass includes all these 13 or more types, that is starts from soda lime glass, lead glass, borosilicate glass, high silica glass, hard glass or potash lime glass, safety glass, optical or Crookes glass, polycrystalline glass, colored glass, toughened glass, glass fill, laminated glass, neutral glass. Now here, these are the pictures of different beautiful glass items, decorative items, glass including glass birds, glass swans. These are all colorful, and deer, colorful, colorful animals. This is an awesome technique to make such amazing animals. This is an awesome technique. How beautiful they are. It's such a creative artwork. Now here you can see colored glass bottles by glass blowing technique, and you can see in the second picture shaping, the man is shaping it while it's very hot. With the help of some holder, he's shaping it, and the torch is used to cut or reshape the area, as when the glass is very hot, it's easily handled, it can be handled easily, and it can easily be reshaped. The bottles are cooled overnight before reaching the final awesome shape. That is, here you can see how he has reshaped or shaped the handle of this beautiful colored bottle. And this is done by amazing glass blowing, forming, cutting technique. This all goes on a studio called Vitrovero Studio, where this is a studio where this amazing glasswork is progressed. Hats off to these people who are, so much engaged day and night to achieve these beautiful colored items for us to enjoy our life with, to make our life more colorful, full of colors. Hats off to them. I hope you like this presentation. I hope you will share with your friends. You will gain knowledge. You will learn a lot from it, and you will like it. See you in my next presentation. Thank you. Thanks.